Okay, so here in this video we're going to find volumes by the disk method. Alright, so the first example is y equals x minus x squared, y equals 0, about the x-axis. So the first step is to get the area. So just like before, you have to get the area bounded by these equations. So I'll set these equal. X minus x squared equals 0. Take out an x, and what's left is 1 minus x equals 0. So x is either 0 or 1. So you got to get the sketch of the region. So when x is 0, y is 0. And when x is 1, y is also 0. If you put 1 in, 1 minus 1 is 0, so you'll get 1, 0. And you can pick an x in between, like a half, and then you'll get a half minus 1/4. So make that 2 quarters minus 1 quarter is a quarter. So over a half up a quarter. And this is a parabola, as you would know, concave downward. Like that. The x-axis is y equals 0. So then this is 0 right here. So that's the area. So I draw my rectangle vertically. And we're going to revolve it about the x-axis, which is here. So since the rectangle is perpendicular to the axis of rotation, meaning the x-axis, and there's no clear piece, it's volume by disk, which equals pi times the definite integral from 0 to 1 of the radius squared. This is the radius of that disk that we're revolving about the x-axis. So the radius is the height of this rectangle. When the rectangle is vertical, the height of the rectangle is top minus bottom. So the top is the function x minus x squared minus the bottom, which is 0 squared dx. And of course that is just x minus x squared squared. So we do have to, simplify that. So I'll square the first term and get x squared. Multiply these two and get negative x cubed, but double it. Square the last, x to the fourth. And this would become then the dx. So this would become then pi times, and I can take that antiderivative now. That would be x to the third over 3 minus 2x to the fourth over 4 plus x to the fifth over 5 from 0 to 1. And I can reduce that down to a half as such and plug in the 1. So I'll get 1/3. This would be minus 1/2 plus 1/5. And of course putting in the 0 is just going to be 0 throughout all of that. And I can get a common denominator here of make everything a 30, so 10 over 10, 15 over 15, and 6 over 6. So that would be 10 over 30 minus 15 over 30 plus 6 over 30. And that here would be negative 5 over 30 plus 6 over 30 would be 1 over 30. So it would be 1 over 30 pi. And of course you can always check your answer on the TI-83. Okay, remember, no volumes can be negative, just like areas cannot be negative. So just make sure that we square things carefully. Square the first, multiply these, you get negative x cubed, but double it, square the last. And the antiderivative would be x to the third over 3 minus 2x to the fourth over 4, which reduces to x to the fourth over 2 plus x to the fifth over 5. And there's that one. Okay, the next one is, suppose we have y equals sine x, y equals 0, excuse me, from 0 to pi. And we revolve it about the x-axis. So then y equals sine x. We know sine is 0 at 0, and at, remember the sketch of sine, the beginning, the middle, and the end are all 0. And the first half is up at 1, and we're only going from 0 to pi. So sine from 0 to pi looks like this. Y equals 0, you do have to draw that. That is the x-axis. So that's the area. Draw the rectangle, illustrating that area. Now we're going to revolve it about the x-axis. The rectangle is perpendicular to the axis of rotation. There's no clear piece, so it's volume by disk, which equals pi times the definite integral from 0 to pi of the radius of that disk squared. So the radius is the top minus the bottom. So it's going to be sine of x minus 0, the quantity squared, dx. So if you remember this one, we have a sine squared x. Remember, a singleton sine to an even power, we have to use the identity 1 minus cosine double the angle over 2, which is 1/2 minus 1/2 cosine of 2x. So then this will become 1/2 minus 1/2 cosine 2x dx. And that antiderivative would become 1/2 x minus 1/2. The antiderivative of cosine is sine 2x. And if I choose u to be 2x, du is 2 dx. Put a 2 in and take out a 1/2. Now that 1/2 times the 1/2 will become 1/4. Just remember to divide by the derivative of 2x. The derivative of 2x is 2, so you divide by that, making that now 1/4. And that's going to go from 0 to pi. And then you can put this in here, and it's not going to be a nice answer, I guess. We'll put in that, and we will get here 1/2 pi and minus 1/4 times the sine of 2 pi, which is 0. Minus 0 into that, minus the sine of 0 is 0. So that's just all gone. So it looks like my volume would be 1/2 pi squared, because the rest of that is 0. So again, the height of the rectangle is top minus bottom, and you square that because that's the radius of your circular disk. And remember that when you squeeze the volume by disk, equals pi times the radius squared times dx. This is the area of your circular disk. This is your depth, and that's how you get volume. So now it's back to this again. This is the radius of that circular disk, and this is its depth, which is dx. The volume is the area, pi r squared, of its surface times its height, which is dx here. I just want to make sure that we talk about the sine squared being the identity 1 minus cosine 2x all over 2. You can split that up to mean 1/2 minus 1/2 cosine 2x, or you could factor out the 1/2 and make it 1 minus cosine 2x. Okay. All right, next is, suppose we have y equals x squared plus 1, y equals 5, and I believe x equals 0, and it's going to be about a line y equals 4 now, not about the x-axis, that is. So you set the equations equal, and you get x squared equals 4, in which x equals plus or minus 2. So here when I graph this one, because we're bounded by the y-axis here, x equals 0 is the y-axis, we can't have a negative x, so we're only talking in the first quadrant. So if x is 2, I get y is 5. There it is. Pick x as 0, and I'll get 1. This is a parabola, x squared plus 1. There it is. And then I'll graph the line y equals 5, which is there. And don't forget, sketch that. X equals 0 is the y-axis. I'll draw my rectangle vertically. And it's going to be about the line, not y equals 4. Make this y equals 5. So it's going to be about the line y equals 5, which is right here. This is the line y equals 5. Notice the rectangle is perpendicular to the axis of rotation. You always want to draw your rectangle right up against the axis of rotation. Draw it right up against it. Right up against the axis of rotation. And when it's perpendicular with no gap in between, it is volume by disk. So it'll be equal to pi times the definite integral from 0 to 2 of the height of the rectangle squared, which is your radius. So it's top minus bottom. The top is 5, and the bottom is that function, x squared plus 1, close it, square it. Don't forget to square it. So it's top minus the bottom squared. Distribute the minus through first, and get that. And then you'll get 4 minus x squared squared. So then that would be equal to pi times the definite integral from 0 to 2. Square the 4, get 16. Multiply double minus 8x squared plus x to the 4th. Square the last, dx. And then taking that antiderivative would be then pi times 16x minus 8/3 x cubed plus x to the 5th over 5 from 0 to 2. And I'm assuming at this point we can put in a 2 and get a common denominator from all of that. Okay, that should not be the issue here. It's just the issue should be the setup. So I can obviously put in a 2 and get 32 minus 8/3 times 8, which would be then 64/3 plus 32 over 5, and get a common denominator from there and get the answer. But the biggest concern is setting it up. Okay, so it's volume by disk, top minus the bottom. The top function is the 5, the y equals 5. The bottom is the function y equals x squared plus 1. Distribute the minus, square it, and then take the antiderivative. Don't forget about the pi in front. Just so you see a variety of functions. So suppose we have y equals e to the x, x equals 0, x equals 1, and it's going to be about the x-axis. So y equals e to the x. When x is 0, y is 1. So this is x equals 0. This is x equals 1. And also, let's throw in there, which we do need, y equals 0. Y equals 0 is the x-axis, right here. This is the area. Draw your rectangle. How does it compare to the axis of rotation? It's perpendicular. So it's volume by disk, which will be equal to pi times the definite integral from 0 to 1 of the height of the rectangle squared, top minus the bottom. The top is e to the x minus the bottom, which is 0. Close it, square it, dx. And e to the x squared, power to a power means you multiply e to the 2x. So this cleans up to be pi times the definite integral from 0 to 1 of e to the 2x dx. And that antiderivative, well, the antiderivative of e is the function itself. The derivative of 2x is 2. Its reciprocal is 1/2. Attach the pi from 0 to 1. So be careful there with that 0 exponent. I'll bring out the 1/2 pi in front. So it's going to be e squared minus e to the 0, which is 1. So then that volume would be 1/2 pi times e squared minus 1, because e to the 0 is 1. Okay, so again, just a little different with the function, the integram being e to the x, but it's volume by disk. Okay, and one more different example that we haven't had before is suppose we have y equals x squared, x equals 0, y equals 1, and y equals 4. So if you draw this and set this equal, this is y equals x squared equals 4, x equals plus or minus 2. So when x is 0, y is 0. And when x is 2, y is 4. Okay, so this is y equals x squared. This is x equals 0, the y-axis. This would be y equals 1. And this would be y equals 4. So the area we're talking about is here. Now in this case, we're going to revolve it about the y-axis. A little different. So therefore, if I try and draw my rectangle this way, it's not perpendicular to the axis of rotation. So therefore, I'm going to draw it this way so that it is perpendicular to the axis of rotation, because it's about the y-axis. But remember, if the rectangle is drawn horizontally, it's got to be a dy in the integrand, which means your limits of integration are in terms of y. So then it's going to be volume again by disk. It's perpendicular to the axis of rotation. Pi times the definite integral from 1 to 4. And the length of your radius, because it's sideways, is right minus left. So the right is x squared. But it's got to be in terms of y. So that means you have to solve this for x. X would be equal to plus or minus root y. But because you're in the first quadrant where x is positive, you will choose the positive root y. So this now becomes the square root of y as a function of y. So this would become root y minus this, which is 0, squared dy. So once again, it's real important to realize that we had to solve this for x, so we get it in terms of y, because the rectangle is drawn horizontally. It's drawn horizontally so that it is perpendicular to the axis of rotation. And these easily undo each other. It's literally just y dy. And that antiderivative would be then y squared over 2 from 1 to 4. And that's going to be easy. Put in the 4. You get 16 over 2 is 8 minus a half. 16 minus 1, that'd be pi times 15 over 2. Okay, 7.5 pi. Okay, and just one more example on that. So suppose we have y equals the square root of x, y equals 2. So if I set these equal to each other, I learned that x would be equal to 4 then, square both sides, x would be equal to 4. And I'm going to revolve it about y equals 2. So y equals x, as we know, is this shape right here. So when x is 0, y is 0. And when x is 4, y is 2. Let's make that 2 then. So there's the square root of x. And there is y equals 2 right here. And also I need to throw in there x equals 0, which is the y-axis. So there's my region. It's bounded by the curve y equals root x, the line y equals 2, and x equals 0. I'm going to revolve it about the line y equals 2. There's my rectangle. There's my area. It's perpendicular to the axis of rotation. So it's volume by disk equals pi times the definite integral from 0 to 4. the height of this is top minus the bottom. So it's going to be 2 minus root x, because the top function is y equals 2. The bottom one is y equals root x. So it's the top function minus the bottom function squared dx. Let's square that. Square the first, multiply, double it, square the last. So that's what that becomes. And that antiderivative would become 4x minus 4 times x to the 3 halves, increasing that by 1, dividing by the new power, plus x squared over 2 from 0 to 4. And again, we can make the substitutions and do the arithmetic from there. Okay? But it would be 2 minus root x, the quantity squared, from 0 to 4 times pi. And that's volume by disk.